Good morning, students. So we have discussed scanline fill algorithm in theoretical part, and we have gone through two different types of algorithms for filling an area, like primitive areas. One is scanline filling algorithm, and another one is seed filling algorithm. In seed filling algorithm, we have again two. One is boundary fill, and another one is flood fill. Okay, so all these concepts we have studied in the theory class. Okay, so now we'll come to the laboratory. So we have a program with respect to the fill area primitives, that is using scanline filling algorithm. We don't have boundary fill or flood fill algorithm in our laboratory. So just they are completely discussed only about scanline fill algorithm. Okay. So the question is something like this. So develop a menu driven program to fill the polygon using a scanline algorithm. You have to write a program in such a way that you have to construct any polygon. So that is of our choice by specifying the vertices and using the geometric primitive functions, and we have to fill that polygon with some specified color. So that is what the question they have given. So now the program and the corresponding logic I'm going to explain in this class. Okay. So let's start with the header files, whatever we know that already include stdlib, include stdio, and include glut.h. Okay, that all the header files, the necessary header files we're going to consider. And we have different functions in our program along with the main function. Okay, so let's start with the main function because all the things will begin from the main function only. Let's start with the main function. Okay, so again, int main, int argc, character star arg here. So your program is going to be initiated through by the command prompt using the inputs from the command prompt. Okay, using that argc and argv, and we're going to initialize our glut. Okay, so from that whatever the inputs received from the command prompt, then it is initializing your glut window. Okay, so next we have the again same function. So as what we discussed in the Bresenham's line drawing algorithm, glut init display mode. So glut single, glut RGB. So that is of constant type we are going to use. So for a two-dimensional object, okay, and is of a buffer. Okay. So next glut init window size. So window size again we are specifying with size 500 500. That is, so starting from origin 0 comma 500 0 comma 500 like that. Okay. So next is glut window position. So it will be like starting from the origin only. So 0 comma 0, that is the window position. So one is display mode, one is window size, and one is window position. So these all the functions will be create glut create window also. So in every program you can able to find out these functions by default in the main function. Okay. So next is glut create window. So in the previous case we have Bresenham's line algorithm. Here I'm going to give the naming like filling a polygon using scanline algorithm. So you can give whatever you want. Just you can give scanline algorithm also. Okay. So next is glut display function display. It is going to call the display function. Okay. So here we have a display function. Okay. So what will happen in the display function? So in order to construct a polygon, so at least we said that three vertices we should have. But in this case, in this example, I am considering four vertices. Okay, so that is x1, y1, x2, y2, and x3, y3, and x4, y4. The corresponding values I am not giving input through the prompt. Okay, directly I am passing the values in my program itself. Okay, you no need to give manually, so it will take the directly input in the program only. If you want to construct a different polygon with different value, you have to modify the values here. Suppose if you want only the triangle kind of thing, then only three set of vertices is sufficient. So I want to construct a polygon with four vertices. Okay, so that's why I've taken x1, y1, x2, y2, x3, y3, and x4, y4. The corresponding coordinate values are given here. Okay, so next is gl clear, gl color buffer. This constant we are going to use to clear the buffer whatever. So we are going to consider in the frame buffer. It is going to clear that buffer. So it is making 0 empty. So next is gl color 3f. So what color you are going to specify for that? So I told, right, the polygon. So so for this polygon, four edges you are going to get because we are considering four vertices. four edges. So what that edges color should be, so that we are going to specify here, either like RGB, this is RGB, so this is the blue color, one presence, one indicates presence of the color, zero indicates absence. So in this case your line should look like a blue color, so that whatever the border color of your polygon. So next is that you're going to using the GL line loop, so you're going to join those vertices, four vertices, using this GL line loop function. So, and what are those four vertices we have considered in the program? So that is GL vertex of F means floating values. If suppose it is giving, it should take the floating values as well. So G2F. So x1 y1, x2 y2, x3 y3, x4 y4, and I'm going to end my function. This you already know, this begin and end function. Okay, in order to construct any geometric primitive. Okay, so this is about the display function, and after that what I am going to call inside that, once that polygon has been constructed, so then we are going to call the scan fill function. Okay, so scan fill function, and then we are going to GL flush. What it will do, it is going to it helps to draw all the objects whatever we are going to constructed using these functions. So it just so next after that I'm going to initialize that my init, I told no already. So just it is going to initialize our viewing port, so that is window. Okay, so window projection area, it is going to initiate. So that is my init here. Again, see, GL clear color, just it is going to set the color and clear the color, and the color, what color it is, it's supposed to be appear, so that so this will be like polygon fill area, which color you're going to fill that polygon. Okay, next point size you're going to specify. So pixel size, it is 1.0, so you can say, you can give like 2.0, 3.0, like that pixel size will be increasing. Okay, so default 1.50. If you want to change, you can change, and the pixel size looks like a little larger in size. So again, GL matrix mode is of like GL projection type, it is going to project on the screen, and load identity, the unique identity matrix we are going to consider along with your GL projections. So then, and we are going to use glue ortho 2D function. So as we are dealing with the two-dimensional, and the corresponding values we are going to specify, that is the floating values we are going to consider in this case. Okay, so next, that is about initialization of your this one, and just main loop, just all the things will be running in the main loop. Okay, so once that is done, so we'll come back to here, the scan fill, right? So scan fill, so we'll go back, the scan fill will take all the four vertices values. Okay, so where is that scan fill function? Here. So the scan fill function, what scan fill function will do? So the main agenda is we have to fill the color, so using scan fill function. So that's what. Okay, so before that we have to find out the edges. How to find out the edges? That will be in the function called edge detect function is there, we are going to detect there. So before that, just you look at that, what are the parameters we are passing in the scan fill function. All the x1 y1 x2 y2 whatever the values are, the same thing again I am going to pass to my scan fill function. Okay, so then what I'm going to consider here, I'm going to consider, so the here two parameters, one is left edge and another one is right edge. Okay, I'm initializing that as an array with the maximum size 500. So that left edge, the array is having a size of maximum 500. So and right edge is also a maximum size 500. Okay, so that is left edge array and right edge array, and int I and y. So I and y are the index values variables I'm going to use in my program. Okay, so just I will show that just the logic or whatever the diagram polygon I considered. Just I'm talking about the four vertices, right? So how I'm going to draw that polygon with certain values. Already values I have defined in the display function, right? So 100, 200, 300, some values I have already defined. No, so using those values, how I am going to, how your polygon looks like. Okay, so that will be here. So just look at this polygon. Okay, so somewhat it looks like this. Okay, so like this. So these are the all called scan lines. So this is your y-axis, this is your x-axis. So just this is the like vertex is called like 200 comma 200. So 100 comma 300, 200 comma 400, 300 comma 300. These values are already specified in my program only. Okay, you remember. So in the display function, I already specify the value. What is the x1 value? what is the y1 value, what is the x2 value, x3 value are predefined in the program. So those only just I am going to show in terms of a picture. Okay, so this is how you are going to get the four vertices are there, right? Okay, so and these are all called scan lines, and the left, these are called left edges. So this one, so this one and this one. Okay, so these two are called left edges, and this right side, so these are called two right edges. Okay, we have uh, two left edges and two right edges in my polygon in this example. Okay, and how we constructed means, so these are the values. Using these values I have plotted my vertex points. Then after that, so I just I have draw the using GL line loop. I am going to connect these vertex, then I got this polygon. So now I want to fill this inside this area, no? So this interior region I have to fill with the color. And as I said, so this border, whatever the color I have specified there, right? So that green, only the blue color is present. So remaining or red and green will be absent. 0.0 comma 0.0 comma 1.0 is there, right? So there, so one means blue is present, RGB, red green absent, blue is present. So this border, whatever you are seeing, no, so this will be appear in blue color. You can change the color also. If you want to make red color, then you have to make 1.0, remaining should be 0. Okay, other green and blue should be absent. Okay, like that you have to change the values, and you can look at the difference. Okay, so this is how your polygon is going to be constructed for the given values, and these are all called left edges, these are all called right edges with the corresponding vertices and the edges. Okay, so next, how the logic, how we are going to build the logic of this scanline fill algorithm. So let's begin. So till now you understood, right? The main logic is residing here only. That's why I'm going to trace from here on. Okay, all remaining are just known functions only. Main logic is residing in this function and its detect function. These two functions are very important. So let's begin with this. Okay, so as I said initially, I'm going to initialize my array size for the left edges as 500 maximum, and right edges as maximum 500. Okay, and int I comma y. So these are the two. So variables I'm going to consider index values. Okay, so look at this. Initially consider the array for both left edges and the right edges size as 500 maximum, that is LE of 500 or RE of 500, and int I comma y represent the index value. So this one, so int I comma y represent the index value. Next is the for loop, right? For I is equal to 0, I is less than 500, I plus plus. Okay, so next is for I is equal to 0, I is less than 500, I plus plus. So I'm going to call the for loop for 500 times. Okay, so I is index, so I'm going to call this for loop for 500 times recursively. So starting from where? So 0 to 499, because the I is condition is less than 500, means when it comes to 499, the iteration it is going to exit from this for loop. Okay, so that is what it's first 500 times from 0 to 499 for filling process. In order to fill the polygon area, so we have to perform those many iterations. That is what the for loop indicates. Okay, so next what I'm going to do, I'm initializing my, so before we know that maximum size is 500, but I'm going to initialize my, so left edge of I, LE of I is equal to 500, and right edge of I equals to 0. Initially I'm going to initialize with the values, so 500 comma 0. So left edge will be 500, right edge will be 0. This I'm going to initialize. This is what, see. So left edge I'm going to initialize to 500, and right edge I'm going to initialize to 0. Okay. So next I'm going to call the edge function. So what is the edge function? So this is the edge detect function. First, that's what. So after plotting the vertex or points, now I am going to detect the edge. Okay. How? So using what you are going to. So I need to pass the variables like x1, y1, x2, y2. So if you are passing the and LE comma RE, okay, left edge, right edge. So I'm going to pass these two set of vertices in order to find out the first left edge. So what is that? So this one. So this is the first left edge I'm going to identifying. Okay. After that I'm going to identify the next left edge. Then after that I'm going to identify this first right edge. Then I'm going to at last I'm going to find out this. I'm going to detect this the final right edge. Okay. So this is the process. First, then I'm going to like this. Then I will come like this. Then I'm going to come back to my original position. So like this, I'm going to find out. So in this direction, I'm going to find out the edges using edge detect function. Okay. So next, I'm going to call the edge detect function. Okay. So first we have to find out the left edge. This is what just I highlighted here in order to difference. Okay. So I'm going to pass the initial value like x1 comma y1 and x2 comma y2. So okay now. So if you are passing, if you are considering these two vertices, then you can able to detect this edge. Then after that x2 comma y2 and x3 comma y3. If you use these two set values, you will get this edge. Then if you use like x3 y3 and x4 y4, then you will get this edge. Then after that, in the last fourth case is x4 y4 and again x1 y1. So then you will get this edge. So like this, I am going to find out all my edges of the polygon. So that is what the explanation here given. After the left edge, we will find out the right edges. So in the edge detect function, first we have to pass two vertices values. That is what I said. So first we have to find out these edges using these values x1, y1, x2, y2. So and the corresponding values already given, already considered in the program. Use the same value, okay, in order to derive. Again, I have mentioned here also. Okay. So once that is done, I will go for this. Again, once that is done, I am going for this. Next, like so, then I am going to finish with my edge detection process. Okay. So that is what we are going to perform in the edge detect function. Okay. So this one. So this is those four function I'm going to use. Look at this example. Okay. So using these values, I'm going to find out my all the four edges and how this logic is going to be built. That is what my next question, right? So that we will discuss. So now it is calling edge detect function, right? So I will go to my edge detect function. It will stop. It will jump to the next function edge detect after that once it reaches that condition. Okay. So this is my first function, that is edge detect. Here again same thing, I'm taking these two coordinate values, that is x1 y1 x2 y2 and my left edge and right edge values. Okay. So after that I'm going to consider my local variables. So I am going to use these variables in my edge detect function. So I'm initializing those for with the floating type. So mx and x temp, these are the local variables, and for index value I'm going to use int I. Okay. So then I'm going to checking this condition. If suppose y2 minus y1 is less than 0. Okay. So I will come back to the logic here. Same thing. That one only I'm explaining here. See. So this is the one. This is the one. Edge detect function is I'm going to start. So next declare the local variables like mx, x temp, and int I index value I'm going to initialize declare. So then check the condition. What is that condition? If y2 minus y1 is less than 0. Okay, here. So just you calculate y2 minus y1. So that is 300 minus 200. Then what is the answer? 100. So y2 minus y1 will give 100. You just come back to the condition. So if 100 is less than 0, no, condition fails. So condition fails. Okay. So if suppose if it is true, suppose if this condition is true, then what you are going to do, you're going to swap the values using the temporary variable. Look at this. If suppose this condition as of now, as of now, for my example, this condition fails, I'm going to the next condition. Suppose if it is true in this case, what I'm going to do, I'm going to swap these values. Okay, so y1 to temporary, again y2 to y1, again temporary to y2, and similarly for x. So just I'm going to swap my values. Okay, so if this is true, but for my example, it is this condition fails. 100 is not less than 0. Okay, so then I'm going to check for the next condition. If y2 minus y1 is not equal to 0, already I have derived y2 minus 1, I already derived, right? Y2 minus 1 100. So if y2 minus y1 is not equal to 0, if 100 is not equal to 0, yes, 100 is not equal to 0, condition is true. Okay, so then I'm going to find the slope. Okay, so the slope equation, so just here see slope equation they have given mx is equal to x2 minus x1 divided by y2 minus y1. So this is the what I'm going to do the calculation here. Then I'm going to, if this is the condition is true, I'm going to find out the slope value. Okay, so that is mx equals to x2 minus x1 divided by y2 minus 1. Substitute the values. X2 is 100 minus x1 is 200, y2 is 300, y1 is 200. Just to do minus 100 plus 100. So minus 1. So mx is equal to minus 1. This is the slope value. Okay. So what I'm going to find out, the slope of this edge I am finding. Okay. The slope for the first left edge I have find out. This is the value. Mx is equal to minus 1. If this condition true, then I'm finding the slope. So what is the next logic? If after finding that slope, I will next jump to the, I'm going to leave the else case. Then, so next is I'm going to assign my x1 value to the x. So that is what initially I have considered here one local variable x. Okay, for this purpose only. I'm assigning my x value, x1 value to x. Okay, so just look at this. Just I'm assigning x1 value to x. What is my x1 value in this case? So x1, what is the x1 value? X1 is like 200, right? So just I'm going to assign that x1 value to x. Now your x contains the value of 200 and slope mx is equal to minus 1. Okay, so next, after that assign is over, next is for loop is there. For I is equal to y1, I is less than or equal to y2, I plus plus. Now I am going to perform how many iterations I am going to perform here. So see, look at this. I is equal to y1, I is less than I, y2 less than equal to y2, I plus plus. So just look, so what is the values we have? You just have written here to for better understanding. So I know x is equal to 200 because I have assigned your x1 value to x. That's why directly I have written x is equal to 200. Next, what is the I is equal to condition? I is equal to y1, right? I is equal to y1. What is the y1 value in this case? 200. So I is equal to 200. Next, what is the next condition? I is less than or equal to y2. I is less than y2. That is I is less than 300. Less than or equal to, sorry, here you put equal. Okay, so less than 300. So y2 is equal to 300. So I have written all the values whatever we are using in our program. Okay, so then your loop, our for loop will be executing from 200 to 300 because see that condition. So I is equal to y1 and I is less than y2 means y1 to y2. This for loop is going to execute from y1 to y2. So what your y1 value contains, it is 200. So and y2 is 300. Okay, so that is till that this for loop is going to execute. So let's look at the first step. Okay, so when I'm entering into the for loop, so initially, so as I said, the first I value will be so 200. So that is the y1. So next is, so as I already told, the left edge is initialized to 500. The RSI is maximum. So sorry, not maximum. So this is, so in this case, in the first sorry, in scan line, go back to scan line program here. See, so I have initialized, right. First is LE left heads to 500 and right heads to 0. That is what I am going to consider here. See this one. So LE of 200, LE of high, what is the I value? 200, right? So that's what LE of 200 is equal to 500 and RE of 200 is equal to 0. So this is, so whatever I have initialized in my scanline function. Okay, that value I am just considering here. So my iteration will start from 200 because the condition is start from y1 and it is ends at y2. Okay, so then if, what is the next condition? So in the exit function, if x is less than LE of I, if x is less than LE of I, so same thing, I am taking the if condition. If x is less than LE of I, so what is the x value? 200 here. So this is a 200 value, I have direct 200, right? X 200 less than LE of I, so that LE of 200. So LE of I means 200, LE of I, so LE of 200 is equal to what? 500. So 200 is less than 500. Yes, condition is true. So next, then what I'm going to do? So just look at the program. If that condition true, I'm going to so assign this value. So LE of I is equal to x value. Okay, so same thing. LE of I is equal to x. So what is this LE of I? I is equal to 200, and what is my x value? That is 200. So now your LE of 200 is containing the value as 200. Okay, so this is the first case, first step for left edge. So next, when you are going for right edge, so similarly, so just look at this condition. So if x is greater than float, that is RE of I. Okay, so let's see, x is greater than RE of 200. Again, I means 200. Okay, so what is the x value? 200 here. So 200. So that 200 is greater than, what is the RE of 200? So RE of 200 is 0. So 200 is greater than 0, as condition true. Then I'm going to assign that value. So RE of 200 is equal to 200. Okay. So look at this here. I'm just assigning that value to that or of I means 200. The iteration is starting from 0 200, not 0. Okay, so because my y1 value is 200, that's why beginning point will be 200 and it is ending at 300. Okay, so from 200 to 300 this iteration is going to happen. So for my first iteration my I value will be 200, next iteration 201, 203, 204, so like till 300 I'm going to perform these iterations in order to get the pixel value. Okay, so after that, so once I have applied these two if conditions with respect to left edge and right edge and whatever the values I derived, so once that is done you are going to calculate the new x value. Okay, the new x value will be calculated using the formula like x is equal to x plus mx. So this is what the formula they are given. X plus is equal to mx means you have to expand this. So this can also be written as x equals to x plus mx. So I already derived mx and I know the x value also. I know both the values so that I can able to derive the new value. So x is equal to, so x is 200 and plus mx is minus 1. So plus into minus minus. So 200 minus 1 equals to 199. So your new x value will be 199. So this is the complete procedure or iteration for the step 1, means for the first iteration, that is when I equals to 200. Okay, so these value will be same for all the iterations. There is no change in this because this is initially we have initialize our value to this 500, left edge to 500 and right edge to 0. So these values will not be changed, but this I value is going to be changing. So now 200, next is 201, 203, 204, like that it is going to increase. Okay, so in the step 2 my I value is 201 now. So previously what it is 200, right? So now it is 201. So similarly you apply for the same thing, whatever we are conditions we have applied this one. So just apply the same thing. X is less than LE of 201. So again 191. So previous 200 it is, now it is 199. So 199 is less than 500. Yes, condition is true. Then now your value will be LE of 201 equals to 199. Similarly right edge also you apply the same if condition and you just derive the value. Then this also will becomes 199. Okay, so next after that you are going to calculate the new x value. So again x is equal to x plus mx. So in the second step what is the x value? That is 199. 199 minus 1, that is 198. So now x value is equal to 198. So like this it is going to keep on decreasing your x value. Okay, until so it will reaches that 100. Okay, so because, so just look at this diagram. So we have the x value is 100 because we are moving from this vertex to this vertex, right? We are finding this edge. So now initially what is this? 200 comma 200. Next is 199 comma 199, 198 comma 198. Like this it is just going, we'll keep on increasing. Okay, so then we'll get till 100 comma 300. Okay, so like this we have to find out all the iterations in order to get this edge. Okay, so these are the steps we have to follow in order to find out the first left edge. Okay, so next, just after that, just I have given so on, you have to perform all the next 203, 204, 205 like that. So I'm going to again, so that you have to perform. Then at the last iteration I'm going to show here, that is the third 300 iteration, I equals to 300 again. So these values I told remain same, and LA of 300 is equal to that time your value will be like 100, and similarly for right edge also 100. So your new x value will also be 100. So your next coordinate value will be what? 100 comma 300. So that I have reached this point. So I have reached this point. I started from here, I equals to 200, and I have ended with I is equal to, sorry, x is equal to 100. So 200 to 100 I have decreased my so x values. Okay, so like that you have to perform the iterations. So okay, so total 300 sorry 100 iterations you have to perform starting from 200 to 300. So next after that, so this is, so that is the calculation. This is the edge detection calculation. Okay, so till now I performed only for the first left edge. Okay, that is x1 y1 x2 y2 coordinate. Similarly you have to find out, that's what I told in the scan fill function. So now I performed only for this edge, okay, to detect the first left edge. So this one, so this is for this. Till now I have calculated this, it's a sample cases I have shown. So this is the first left edge. Okay, so similarly using this function again x2 y2 x3 y3, I'm going to find out this edge. Okay, so this edge I'm going to find out. So next is x3 y3 x4 y4. So using that I'm going to find out this edge. Okay, so next x4 y4 x1 y1. So using that the final right edge I'm going to find out. So this is how you're going to calculate the edges of your polygon. So that's what we are calling for edge detect function. And once that call, it will go to the control to this edge detect function. As I told now, so it is going to perform accordingly. So you have to find out the edges using this logic. I have traced here for one edge. Similarly, you have to follow for all the edges using the given input values. Okay, so this is complete edge detect function, how it is going to work. So that's what I will explained here. So next we have to find out the next left edge using this function, and again right edges we're going to find out accordingly using these two function. Okay, so once that edge detection done, then we will start filling the areas. Okay, so once we have identified, once we have complete the detection of the edges, then we are going to start filling the color from bottom to top. Okay, so for that, what is the logic we are using? So just I will go to the program once again. So now scan fill. So now this is over, right? So once whenever you call this, it will control go to the edge detect and it is going to perform those operation. Once the edges has been constructed, now we'll continue with this program. Scan fill function is going to continue. Now for y is equal to 0, y is less than 500, y plus plus. As we know, so minimum value it's starting from y min to y max. What is the y minimum value? 0, and y max will be 500. Okay, so these many iterations it has to perform in order to fill the color. Okay, so next, if suppose le left edge of y is less than right edge of y, so what is the value? See, so left edge of y is less than or equal to right edge of y. So always your left edge values will be always less than or equal to right edge of y only, because your right edges values, whenever your right edges, the x value or the corresponding coordinates value will be in the increasing order only. So that's why this condition is always true. There is no condition failure in this case. Okay, that's why directly I'm going to the for loop. So if I for I is equal to LA of y and I is less than RE of y, I plus plus. So this is the next condition. This condition is always true. You no need to worry about this. Okay, that's why directly I will go to the this condition. If I is LA of y and I is less than RE of y, I plus plus. So I'm going to use that function for loop. So then we are going to fill the polygon with the specified color one by one from bottom to top. That is nothing but y minimum to y maximum. So I will show here in the diagram. So this is the y minimum value. Okay, so y value started from here, right? So like this it is going to 0 from bottom to top. So like this I have shown in the dotted lines. So like that it started from here and it's keep on filling this color. Okay, from left edge to right edge, left edge to right edge. So like this it's keep on filling the color. Okay, till that it is till the y max value it reaches. So then it will stop filling the color. Okay, so by like that, it is the interior part is going to fill with some color and your polygon border will be in one color. So that is how the logic works. Okay, so next in order to draw the pixel, we are using the draw pixel function by passing the values I comma y. So whatever the values we are considering here, y value along with the index value are going to pass. So using those values, the coloring that we are going to identify the pixels and we have to fill the color. Okay, so this is how the logic we are going to build in order to uh, fill the color. Okay, for any given polygon. So this is how finally, see, look at this. So this will be filling with some color. Okay, so these are the scan lines passes through the polygon. So see, these are the interior region and it will be filled with some specified color. So finally it looks some, actually it is filled with color. I will show in the execution, but just you remember how it looks like. So this is how the complete logic of your scanline algorithm will works. So I will show the execution now. So same program I have just uh, written here. Okay, just you go to the again build solution. It will check for any error is there or not. If any error, it will show. Otherwise, it will show like succeeded. Okay. Otherwise, fail means it will throw error if any error is there. Okay. Just then you execute. Click on this. You're going to get the output like this. See, look at this example. So same thing, whatever I drawn in my what is the tracing of the program. So just you like the same thing I got, right? See, so this is the border, blue color border, because I have given blue RGB in that. No, I just have make it presence, blue color as a presence. So that's why your border will be blue color, and inside see fill with the green color. So just I will expand, then you will get, see, this border is, see, completely it's filled with blue color. So border will be, so this is the first left edge, this is the second left edge, and this is the first right edge, and this is the second right edge. Two left edge, two right edges, and these are the intermediate. You can able to see these are the pixels. So when you minimize, you will not clearly see the pixels. It will show complete solid fill color, but if we expand, then you will can able to understand. See, we have so many n number of pixels inside this your polygon, so with the green color. Okay, so that is the, here you can change the colors also. I will show the different color here. So if you want to just you change the color, you see green color I make present, right? Just I will make it 0, and I will give red color. Okay, just I'm going to make red color as presents. Okay, then and border also, I want to give the border color also. So instead of here blue color is present, just I'm going to make it absent. I'm going to give just green color as present. Okay, so now you save your program once again. So go to build solution. So just yes, so build it, just it is going to compile. Okay, so next you're going to execute again. So look at this. So now your border will be appear as green color, because I made it as green color present, and inside I want to I changed to green to red color. Okay, so just I want to expand this. You look like this. See, so this is the green color border. This is the outer edges, and inside the pixels are looks like this. See, red color. Okay, so like this you're going to fill the color for the given polygon, and you can change the coordinate values also. This is not same one. You can here, if you want different polygon, you can change the values here. So instead of 200, you can give 300. Just let's try how the other polygon you may get. Just randomly I'm changing the values. We'll see how it will be changing. 300 to 400, and x2 I'll give 200. Let it y 300 only. Let x3 and x 300, y3 300. Simply I given random value. There is no special logic in that. Just I try to save the program. Just to rebuild it. Okay, I'm going to execute again. See, like this. So this is again something different polygon. Okay, so these are the four different vertices and how it looks like. So like this I'm going to get. Okay, now this is the one vertices, this is the one vertex, this is the one vertex, another one. So total four vertex and four edges. One, two, three, four. Four edges we have. So like this you can give the input, different input values, and accordingly you can change the polygon shape also, and you can give different border colors for the polygon, sorry, edge color, and inside area also you can fill with a different color. Okay, I have shown for both the cases color as well as the different polygon what we can able to construct. Okay, so this is how you are going to execute your the scan line fill polygon fill algorithm. Okay, so if you have any doubt, please let me know, so we will discuss again. Thank you.